Hello students, welcome to another class of your Java lab. The topic we are going to cover today is abstraction. Even before we jump into the topic of abstraction in Java, let's understand what abstraction actually means. Now some of you have and I don't know, maybe you have visited some photo gallery or you went to the workshop of some painter or someone like that, and you have come across the term abstract art. Maybe it might have looked like something like this. Let's just see. I will just put up an abstract art if possible on the screen. So this is an abstract art. I pulled up the file from Google, and even I didn't understand what this abstract art actually meant. But from a painter's point of view, they actually, I mean, the person who has painted this image, that person had some idea in his or her mind that what the meaning will be behind the entire drawing. But we as laymen, we don't understand the meaning. But another painter who is familiar with the art and stuff, they will be able to understand what the inner meaning is. So you can from this entire concept you can understand that abstraction is something which is creating a curtain of vagueness between the inner meaning and someone who is coming from outside. Laymen like us, we are the outside users, and the painter might be on the first chance doesn't want us to understand the inner meaning, but it will be easily understandable to another painter who is familiar with this kind of art. Later on I researched and I found out that this entire art is about fire and smoke and something like that. So okay, enough of art, so let's just come back to Java. So as we saw from the painting that we didn't understand the meaning of it on the first go, but as and when we researched and found out the inner meaning, we got a fair idea. Okay, this is an art about smoke and fire and something like that. So similar way in Java, abstraction is a concept of object oriented programming language. What does abstraction do? It hides the inner details and shows only the functionality. This is a very bookish definition, and you might have already read it or have gone through it. So what does hiding details means? Hiding details or hiding inner details means hiding the implementation details, as in which class it has been implemented or what methods have been implemented and stuff like that. I mean, when I say implemented, I mean what are the functionalities that we have included in those methods. But when I say we have made this functionality public, that means if you are an user and you are trying to use that the methods of that class, you will know that the add method is used to do a sum, but you will never get to know rather that whether the add method is making a sum of two integers or two float values or two double values, or what is going on inside that method. So that will only be that will only be in the knowledge of the person who has written the code. So this is what abstraction does. Similarly, say you have gone to an ATM counter. You have gone to an ATM to draw out some money. So in front of the ATM machine, you stand, you put in your card, you put in your password or PIN, and you draw money. You follow all the instructions that are coming on the GUI screen of the ATM machine, but you never go through the algorithm that is going behind, the entire processing of the machine. Same way, if, say, whenever you're using WhatsApp or whenever you're using a simple SMS, the technique. So what are you doing? You are writing down, you're typing down the message in the text area, and you are selecting the contact and you are hitting the send button. But do we particularly go through the details of the mechanism that is running at the back end of the application? No. So what is happening is that we are facing an abstraction. That means we are facing only the exterior. We are using it, we are using the functionality of that application, but we don't know the implementation of the application. Same way, abstraction works in Java. With a few more coding and some rules and regulations, we will get a good grip on this particular concept. And this is a very, very, very important concept for object-oriented programming language. So let's just see how it works. So this is the basic definition of abstraction. And what does abstraction do? Abstraction is used for hiding internal details and showing only functionality. Now, how do we implement the concept of abstraction? Because again and again I'm telling you that abstraction is a concept, just like inheritance. Inheritance is a concept, we implement it with something. So abstraction is also a concept, and we implement abstraction either with abstract class, or the second option is interface, right? Abstract class or interface. And now as the video proceeds, we will get to know more about abstract class, and maybe in the next video we will be covering interface. So our next topic of discussion will be what is abstract class, why do we need an abstract class, rules for implementing abstract class, and things like that. So what is an abstract class? Abstract class acts as boundary between implementation method and its functionality. It acts as a boundary, or it creates a curtain between the implementation method, the method which is which holds the entire implementation, and the functionality. Functionality may be described as where the method is being called. You as an outsider will be able to call the method, but you will never get to see what is written inside the method. So this is done by abstraction. And what is the syntax of writing an abstract class? So you add this keyword abstract followed by the normal nomenclature of how we write a class. Like the keyword class followed by the class name, open brace and closing brace. This is the scope of the class. This is the scope of the class. So what are we adding in front of the normal nomenclature of a simple class? That keyword abstract. As soon as we add the keyword abstract, it becomes an abstract class. Now, how is this abstract class different from your normal class? In an abstract class, on the first two, we will understand that in an abstract class, we do not, I am repeating again, we do not write the entire method. Rather, we write abstract method. But we can add non-abstract methods in abstract class also. But the main flavor of abstract class comes from abstract methods, and these abstract classes, when extended by normal classes, in the normal classes we implement these abstract methods. How do we write an abstract method? Simple. Again, add the keyword abstract, then say return type, and method is say add. So, done. This is how we write abstract method. An abstract class can also hold non-abstract methods. In the coming examples, we will be coming across it. But before that, we have to learn why do we need an abstract class, and also what are the rules of writing an abstract class. So here is a list of points explaining why do we need an abstract class. I would recommend that as soon as you come to this part of the video, you take out your copy and start making notes, because this is a type of a question which will come in your university exam. I mean, there's a high probability that it may come in your university exam. So writing these 5 or 6 points may fetch you good marks. So coming to the first point, why do we need an abstract class? It is used for default functionality. What do we understand by that? Abstract classes are designed to provide default functionality of the defined method for all the subclasses. Okay. Now next comes template. Abstract classes provide a template for future specific classes. That means in the abstract class, it holds a template of how the subclasses that will be extending the abstract class should look like. The basic structure of the subclasses are defined in the abstract class. It holds a template or a blueprint. Code reusability. Abstract classes allow code reusability. Now separate method definition. Separate method definition. Abstract classes allow abstract classes separates method definition from inherited subclass. Like in one of, I mean, one abstract class can be inherited by innumerable subclasses. So in one subclass, whatever the method definition is, it is separated from the method definition of another subclass which is inheriting the abstract class, and also the abstract class which is holding the blueprint of the abstract method. That abstract method also does not have to go through any change on the coding part. It can straight away get the definition of the the code of that particular method in the extended subclass, right? Okay. Next thing is that loose coupling. This is a very interesting topic, and we will be covering this in our interface video. As of now, just understand that abstract classes helps the user to achieve loose coupling between the class members and class methods. How do we do that? I'll just give a brief definition, or a brief idea that how do we apply loose coupling. Loose coupling means whenever we are adding something new, it will not hamper the previous code. We don't have to change the previous code. All we have to do is loosely couple, or loosely couple means just add the new concept, or add the new thing that is coming inside our code without having to make any changes to the previous one. How do we do that? You will be covering interface. Interface is used for implementation of abstraction. So in interface, what do? We define the interface, and the same interface is implemented in different classes. So if a new class is introduced in our code, we don't have to change the interface anymore. All we will be doing is just fetching the interface and implementing it in the new class. That way, all the other previous classes as well as the interface, they will not go through any change. All the change that needs to be done will be in the newly added class. This is loose coupling. Loose coupling generally it reduces the dependencies between classes and methods and interface. That is the entire concept of loose coupling. Okay. The last point is dynamic method resolution. So abstract classes support dynamic method resolution in runtime. Again, I'm telling you that it is abstract classes support dynamic method resolution in runtime. Okay. So next we'll be seeing what are the rules of writing down an abstract class. So here comes the rules for abstract classes. The first rule, this should be the first rule actually, but anyways, you go through the rules. It is not written in any chronological order. So anyway, you will get whatever I am trying to convey to you. So the first thing is that it cannot be instantiated. Now you have already covered this concept of class in one of your Java lab. So quickly write down in the comment section what do you understand by instantiating a class. Just pause the video and write down in the comment section what do you understand by the term instantiation of a class. Okay, now we will be discussing what we understand by it. It means that we can create a reference of the abstract class, but we cannot create an object of that class calling a constructor. There might be constructors in the abstract class also, but we cannot call the constructor and we cannot create an object. What we mean by creating an object? We mean that we cannot allocate memory to that object using constructor of abstract class. That is not possible, because anything which is abstract is actually vague. So, having that constructor doesn't actually make any sense. So, we cannot create an object of the abstract class. We can create object of the class that extends the abstract. The normal class which is extending the abstract class, we can create object of that. Or rather, we can do like this: abstract class object equals to new, and we call the constructor of the normal. That is possible, but we cannot create an object of abstract class. That means we cannot allocate memory to that class using the constructor of abstract class. Okay. Next is that it can have final methods. In I have prepared like 2 or 3 examples, or maybe 4 examples. So in any of the examples, you may come across this thing, and if not, you can actually try out this thing in your coding section, and you can show me that, man, this is how final methods when implemented in abstract class, this is how it works, because you already have you already know how to write final methods. Same way it will work. Next is that abstract class must be declared using abstract keyword. That I have already shown in how to write syntax. Normal class nomenclature, open brace, close brace, and before the normal class nomenclature, you just put the abstract word, the keyword. It can have both abstract and non-abstract methods. I have already mentioned this before. You can write abstract method. Abstract method means there will only be a declaration of the method, but you will not write the definition or the body of the method. And also, obviously, non-abstract method means there can be methods which have the body. So, next is it can have constructors and static methods too. In an abstract class, we can have both constructors and static methods. So enough of the theory portion. Let's jump into how we write the code, and whatever I write on the board, I will be explaining with a code that we have already prepared for you in Netbeans. I hope the entire board is visible to you. So this is our first example of abstract class with abstract method. What have we done? We have created a class bike, which is an abstract class. I have put the abstract keyword here. Next, this is the scope of the abstract class. The abstract class opens here and ends here. What is the abstract class holding? The abstract class is holding a method run, which has a return type void. That means it is not going to return anything, and it is preceded by this keyword abstract. So that means this is also an abstract method. Now, how do we implement it? A normal class Honda. See, here is no keyword here. So this is the normal class Honda. This Honda class extends the bike. The abstract class is extended by a normal class. That means bike is being the child, the parent class, and Honda is being the child class. Right? You can understand this thing. This is the parent. This is the child. So in the child class, we are extending the parent class. Next, what we have to do, here we have an abstract method. We don't have any definition of that method. There is the method body. So we need to define that method. We need to implement that method. How we are doing this? Simple. We are overriding the run method. Whenever you are coding in Netbeans, whenever you write this code in Netbeans, they will be asking you to annotate this symbol here. @override. Even if you don't give the annotation, it doesn't matter, but Netbeans will ask you to do it anyways. So that way you can understand that simply what we are doing is that this abstract method run is being overridden in the Honda class. What we are doing, we are simply giving a print statement, system.out.println, and Honda is ready. Now, people who still have confusion, and it is for actually everyone, that what will be the name of this Java file? Quickly write down in the comment section what will be the name of this Java file. Just mention example 1. The name of the Java file will be this. Okay. That way I will be able to understand that whether you are clear with the concept of naming, how to name a Java file. Okay, so next what we are doing, we are having public static void main string argument. Inside that, I already told you that we can create a reference of the abstract class, but we cannot create an object of the abstract class using constructor of that class. Though an abstract class can have constructor, but we cannot use the that constructor to create object of that class. So here the abstract class is bike. So by B till here, if we omit this portion of, from equal to and whatever is written in the right side, if we omit this portion and if we put a semicolon here, that will mean that we are creating a reference of by class. Next, if we want to convert that reference to an object, we have to give it some memory. Some memory needs to be allocated. So how do we do that? Using the new keyword, and we are calling the default constructor of Honda class. The class which is extending the abstract class, we are calling the default constructor of this Honda class to create the object B. Next, what we are doing, we are calling b dot run. Well, now, do you have any idea where this b dot run will point to? Will it be this run method or will it be this run method? Obviously, it will be this run method. Wherever the method definition is available, it will point there. So b dot run, we have created an object B using the default constructor of Honda class, so that b dot run is pointing to this run method, and the output should be Honda is running, but we will be seeing it in Netbeans that what the output is what the output in practicality is coming to be. So this is the code. It is the same code that I have already mentioned in board. So what we are doing, abstract class by, inside that we are having this abstract void run. Whenever you write in Netbeans, you will be finding that Netbeans itself, it causes some kind of indentation. But even if you don't follow this indentation, it will not create any code error because this is not Python. In Python, the indentation actually holds some meaning. Next, what we are doing, class. This is now people who are still having confusion and what the file name should be. This should be the name of the file. This class name should be the name of the file because within this class we are having the main method. So instead of Honda, I have named this class as ex underscore abcl, which extends the bike class, which is the abstract class. Netbeans itself has given this annotation at the rate override. Next, we are implementing, or rather, we are giving the definition of the run method. Inside that, I have given a simple print statement that Honda is running safely. We are having the main method. Inside the main method, on the board, I have shown you that bike b equals to new Honda. Same thing here, bike obj equals to new and the class name, which is extending the abstract class, and using that object we are calling the method. So let's just see what the output will be. Just wait for a minute. Okay. So here we have got the output. Honda is running safely. I have highlighted the output. So now you can understand that how we are put. This is a very simple skeleton example of abstract class and abstract method. How we use abstract class and abstract method. We will be jumping to the next example. That will be example 2. So this is our example 2. In this example, what we have done is that inside an abstract class shape, we have created an abstract method area which will be having parameters int L and int B, and we have closed this abstract class here. Okay. Next, what we are doing, inside class rectangle, we are extending this shape class, this abstract shape class. So rectangle is becoming a subclass of shape class. Inside rectangle, what we have to do, we have to define this abstract method which is inside the abstract class. So what we are doing, void area int L and int B, we are simply putting a print statement. We are returning calculating the area of the rectangle with length into break. And we have closed the method, we have closed this class here. The class rectangle ends here. Okay. Next, what we are doing, class square. This is why I particularly chose this example to make you understand that this void area is getting overridden, but it is not getting overloaded. See, in square, we don't need a breadth for area calculation. All we need is a length for area calculation, but still we have to give this breadth parameter, because in the abstract method void, abstract method area, we have this int L and int B. So int B, though it is not useful, still we have to mention it. had it been method overloading, we could have omitted this int b because we can change the list of parameters. But in method overriding, we cannot change the list of parameters. So though we don't need int b, we still have to mention int b. This shows that void area is actually method overriding. Okay, implementation of void area is actually method overriding. So what we have done, simply a print statement, calculation of area, and we know that side squared is gives the area of a square. So side square means length squared will only do, so L into L. Here we are doing a length into breadth, but here we are doing length into length. Breadth, though we are getting the value, but we are not going to use it. Next, again comment down below that what will be the file name for this example 2. Just mention example 2, file name will be this. Okay. So next, inside class test, we are having the public static void main, the main method. Again, what we are doing here, shape S1. Forget equals to new rectangle, that part. If we write only shape S1, what do we mean? Comment down below and tell me that what do we understand if we put a semicolon here and write shape S1 semicolon. So what does that mean? Okay, so what we are doing here, shape S1 equals to new rectangle. So we are creating an object S1 using the constructor of the rectangle class which have extended the abstract class shape. And next we are using that object, we are calling the area method by passing parameters 5, 2. So which area method will be called? Since we are creating object using the constructor of rectangle class, we will be calling the area of the rectangle class itself. So S1 dot area will be calling this area where L will be getting the value equals to 5 and breadth will be getting the value equals to 2. So 5 into 2, this is supposedly going to be the, giving the output as 10. Next, what we have done, shape S2 equals to new square. So what we are doing, we are creating an object S2 using the constructor of square class which has extended the abstract class shape. And using that object, we are calling the method area and passing the parameters 5, 0. Why have I passed the parameter 0? Because anyways, we are not going to use the break. So even if you pass here 6, not 0 but 6, still it will be giving whatever area it calculates out of 5 square. So S2 dot area points to this method void area inside, which has been implemented inside the square class, and here we are calculating area equals to L will be equals to 5, and if we are passing 5, 6, then breadth will be equal to 6. But if we are calculating the area as 5 square, so the supposedly the output should be 25. Okay. Now, we have coded this same thing in Netbeans, so we'll be jumping inside the code and see what the actual output is coming to be. So this is the example of the shape class thing that we already did on board. So what I have done is that there is an abstract class shape. Inside that we have an abstract method area where we have these parameters int L and int p. So what we are doing in class rectangle, we are extending this abstract class shape and we are overriding. See, we have got the annotation from Netbeans. So we are overriding the method area where L and B will be passed as values from the main method, and we are calculating the area of the rectangle with L into B as this formula, length into breadth. We have the rectangle class closes here because the area includes here. Whenever you are clicking on a brace in Netbeans, it will highlight the opening brace also. That way it is easier to track where the brace is opening and what is the scope of that entire method or class. Okay. So next what we are doing here, the rectangle class ends. Next, inside the square class, we are extending the abstract class shape, and we are overriding the method area where int L and int B is there. Though we are not using B, still B we have to write because that is the signature of the abstract method area. And we are calculating the area of square with the formula length into length, or rather square side into side. Next, here those who are still having a problem as what the file name should be, the file name is this abstract shape test. This is the file name. follow the cursor wherever I am pointing it. So abstract shape test dot java, because this is the class in which we are having the main method. Next, what we have done, we have created an object S1 using the constructor of rectangle class, and you with the help of that object S1 we have called the area which is defined inside the rectangle class by passing 5 comma 2. Okay, so here let L is equals to 5 and B equals to 2, and that will be we'll be getting the area length into breadth. Same way for S2, we are creating S2 as the object of using the default constructor of square class, and we are calling the area that has been defined inside the square class using that object. We are passing the parameters 5 comma 0. Let's just make this some non-zero value. So if it is 5 comma 3, what will be the output? So this is the class abstraction test. If I run the file, what will be the output? Let's just see. So area of rectangle is 10 because we have passed 5 comma 2, so 5 into 2 is 10, and area of square is 25. Though we have passed 5 in comma 3, it has called the area that has been implemented inside the square class, and thereby the area calculated there was length into length, and L is getting the value 5, so the area we are getting is 5 into 5 equals to 25. Is that okay? So next we will be jumping to the third example. So this is our third example. Uh, the only difference is that in this particular line and this particular line. Just I have taken this example to show you that not only can we create abstract methods of return type void, but we can also create abstract methods of any particular return type. Right? So what we have done inside abstract class bank, we have created a method getInterest, which is having a return type, which will be giving a integer type return, and it is an abstract method. The abstract class bank ends here. The class SBI, which is a normal class, it extends the abstract class bank. Inside that we get the define the method getInterest, and since it is giving an integer type return, so we are returning the value 7 here. Supposedly 7% is the rate of interest that SBI is giving. Same way, we have implemented class PNB, and with PNB is extending this abstract class bank, and PNB, as for the getInterest method definition, it is returning the interest rate as supposedly 8. Now, what we have done inside class test, we have given the main method PSVM, public static void main string argument. Here, what we have done, not only, I mean, it's not mandatory that every time you have to write bank B equals to new SBI, bank B equals to new PNB. No, we can simply create a reference of bank, put a semicolon here. I guess while drawing the circle, I missed the semicolon. I'm putting the semicolon again. Bank B, this is a reference of bank, abstract class bank. Now we are allocating memory to this particular reference. What we are doing, bank B, so B equals to new SBI. We are using the new keyword, and we are calling the default constructor of class SBI, and inside after that what we are doing, we are simply printing SBI plus B dot get interest. B dot get interest, what will it do? This B dot getInterest will simply point to the method getInterest that has been defined under SBI, because this, while B dot getInterest comes, I mean compiler comes to this line of control, rather this line, the control moves to this particular getInterest, because here B has been created using the default constructor of SBI class, right? So obviously the getInterest method that has been defined as inside SBI class will be called, and we are supposedly getting an output of 7. So SBI dot 7, this should be the output. Again, next thing, same thing is happening for PNB. We can use the same reference B. Same reference B is being used to create an object using the new keyword and the default constructor of class PNB. And after that, we are printing that rate of interest that is getting returned. So S of B, P and B dot get interest. This B dot get interest will be pointing to this particular get interest method that has been defined inside the P and B class. We are allocating memory to this particular reference using the constructor of P and B. So when this object is being used, it will use to call the get interest method. It will be calling the get interest method of P and B class. Next, we will be seeing the same implementation in Netbeans, and we will see what the output is. So this is the implementation of the third example in Netbeans. What we have done, we have created an abstract class bank, and inside that we have created an abstract method get rate of interest. It is same as get interest that I have already written on the code. Get rate of interest, and it is having a return type int. So in class SBI, which is a subclass which is extending the abstract class bank, we are overriding this get rate of interest method, and we are returning the value 7 here. The the class SBI ends here. Same goes for PNB. We are extending the bank class, the abstract class bank. We are overriding get rate of interest, and since it is having our integer type return, so we are returning 8 here, and here we end the PNB. Okay. Let's just scroll down a bit. Yes. So next is that the class abstract bank. This is also the name of the file abstract underscore bank, because this is the class that is holding the main method. Here we have written the main method. We have created a reference of bank. Bank B semicolon. This is the reference of abstract class bank. Next, what we are doing, we are allocating memory for this particular reference B, and we are making it an object. While creating an object, we are using the default constructor of SBI. Therefore, with B as this object, when we drive B dot get rate of interest, it should be calling the rate of interest of SBI. So for the first line, the output should be what is the rate of interest? 8. So no, sorry, the rate of interest is 7 for SBI. So for the first line, the output should be 7. And next, when we are writing B equals to new PNB, when we are writing B equals to new PNB, yes, this one. So we are allocating memory to the reference B using the new keyword and the default constructor of PNB. Okay. So when we are writing B dot get interest, get rate of interest, we are calling the get rate of interest method that has been defined inside PNB, and therefore the second line should be giving the output as 8. So let's just find out this and see what the output is actually coming to be. Okay. The first line gave rate of interest is 7, which is the rate of interest for SBI. Therefore, you can understand that yes, actually this B is calling the get rate of interest method that has been defined inside SBI, because it is giving the return as 7. And next we are getting the return as 8. Therefore, the next B dot get rate of interest is actually returning the interest rate that has been allotted for PL. Okay. So last we will be jumping to the last example, example 4. Now we come to the last example of this topic, example 4. This is a very important example, and when we will be seeing it in code, we will get a better idea. But I'm trying to explain as much as possible as of here. So what we have done, we have created an abstract class by. Here in this example, we will see the creation of an abstract class having abstract method, normal method, and constructor inside it. How everything is being compiled in one class and how we are using it. Okay. So what we have done, we have created an abstract class by. Inside that, we have this constructor of by class. How do we identify a constructor? Please comment down below. Just write quickly in a comment that how do we differentiate between a method and a constructor. So this is a constructor of byte class, because this is having the same name as this class and we are not having the return type. So this is a constructor, and inside this constructor what we have written, system.out.println byte is clear. So the constructor of byte class has this print statement, byte is created. Next we are having, this is a constructor. Okay. next we are having an abstract method, and obviously since it's an abstract method, we will not be having its body here, but we will be having its body inside the subclass which extends this abstract class. Next, what we are having? We are having a normal method. This is a normal method with the method body being defined here. The method has already been defined here. So earlier we came across this point that inside an abstract class we can have both abstract method as well as non-abstract method. So this is a normal method or a non-abstract method. It's changed here. So what we are doing here inside that we are simply printing here is changed. Next, what we are doing, yes, this change here method ends here, and this is the scope of that abstract class that ends here. The abstract class has ended. Next, we are continuing with the program. This is class Honda, which is a subclass, and it extends the abstract class by. Inside that, do we need to implement anything other than the abstract method? No, obviously, because the non-abstract method has already got its definition, the constructor is deciding here. If we want to add a constructor of Honda class, that's up to us. But what we have to like implement, we have to implement the abstract method that has been declared inside the abstract class. So here we are overriding that method void run, and inside that we are simply printing Honda is run. Next, this is the scope of the Honda class. The Honda class also ends here. Next, inside class test vehicle, we are having our main method public static void main. This is the most trickiest part. This is the most trickiest part. Bike B equals to new Honda. Okay. Why I am calling this the most trickiest part? I will explain it. You will get a better understanding when we code and we make some changes in the code. We will get a better understanding. As of now, you have already understood that what is the concept about reference. So B is a reference of class by, and it is converting or it is getting the formation of an object when memory is being allocated to it using the new keyword and the default constructor of Honda. We have not created any default constructor. I mean, obviously, it's a default constructor, so we don't need to create it. B, using B, we are calling the method run. So using B, we are calling the method run that has got its definition inside the Honda class, which is subclass of the abstract class bike. And using this B, this object B, we can call the non-abstract method. The non-abstract method which has got its definition inside the abstract class. What we are doing using this object, we are calling B. Using B, we are calling the non-abstract method which got its definition inside the abstract class. But when we run it, what will be the output? First, the output will be bike is created. Next, the output will be Honda is running. Third line output will be gear changed. So, though we are creating the object B using the constructor of Honda class, yet we will be getting the output of the constructor bike. We will see this. What happens is that if we don't have a constructor of bike class, if this bike was not there, then the default constructor of Honda is called. If constructor of bike class is there, then along with the default constructor of Honda, which is actually not having any print statement, the constructor of bike class is also called. If constructor of Honda class is created, then both the constructors are called. We will show this in code that if we are not having this bike constructor, we are only creating, this B reference is getting the shape of an object using the constructor of Honda class. Next, if we have a constructor of bike class, then we are along with the default constructor of Honda, the constructor of bike class is also called. If we have a defined constructor of Honda class, then both the constructors are called. I will show you in code how that happens. So this is the code, the same code that we have written on board. I have put it up in Netbeans. So what we are doing, we have created an abstract class bike one. Inside that, we are having the constructor of bike one. bike 1 we have written bike is created. Next we are having this abstract method run, and we are having the non-abstract method change gear, where we have simply written that gear is changed. Here we are here we are closing the change gear method, and here the scope of abstract class bike 1 ends. Next what we have done, let's just scroll down a bit. Yes, class Honda extends bike 1. So Honda becomes the subclass which extends the abstract class bike 1. Inside that, as for now, let's just comment this out. Comment this out, by that I mean I'm commenting out the constructor of Honda. First, I need to show you how it works without the constructor of Honda. Next, we will be showing how it works with the constructor of Honda. So simply in the first go, what we are doing, we are overriding the abstract method run inside the Honda class, and what we have done, Honda running safely. We have given this print statement. So in the class abstract vehicle which holds the main method, what we are doing, we are creating bike obj equals to new Honda. So this reference of abstract class bike is getting shape, or rather it's getting memory allocated to it, and it's becoming an object after we use this new keyword and we use the default constructor of Honda. Why I am telling default constructor of Honda? Because I have commented out the defined constructor. So as of now it is using the default constructor of Honda, and since we have this particular constructor bike 1, it will also be using the constructor of bike 1. Okay, so what happens is that we will be using that obj, we will be calling the overridden run method inside the Honda class. Inside the Honda class, the overridden run method, this one. Okay, and what we are doing, obj.change gear, using that object we are calling the non-abstract method that has been defined inside the abstract class. So first let's just run this and see what the output is coming to be. Okay. So what we are getting, bike is created. So you can understand bike is created is the print statement of the constructor of bike class, abstract class bike. Next we are getting Honda running safely, because the overridden run method is having the print statement as Honda running safely. And next we have this gear change, that is the print statement of the non-abstract method, gear changed. Okay, now what happens if we have both the constructors, by that means I mean that the constructor of class bike as well as the constructor of class Honda. I am removing the comment. So this is an abstract, this is an active constructor of class Honda. So inside that, what we are having the print statement as Honda is created. So what I had claimed before is that when we are having both the constructors will be called. So now if I run the code, there after bike is created, there should be a line as Honda is created. Let's see if that comes. Other than that, I have not made any changes to the code, so there will be no other changes. So what we do is that we run the file. So we get the output, bike is created, Honda is created. That means the constructor of bike class is called, the constructor of Honda class is called, and next the other two methods that were called previously, it is called in the same way. Now you may ask me that, ma'am, since there is the constructor of bike class, why can't we create an object of that class? I mean, since I was repeatedly telling you that we can create a reference of the abstract class, but we cannot use that constructor of abstract class to create an object. So is it true? Like, is it true, or can we actually call the constructor of an abstract class and can we create an object? So here I have written the code, I had commented out because it is a wrong line. It will give us error. So let's just comment of the line, and as soon as we comment of the line, what we are doing is that we are using the bike 1, which is the abstract class. We are giving the reference name and we are trying to create an object of that abstract class using the constructor of abstract class. Now we are already having the constructor of abstract class, which has the print statement as bike is created, so we can easily use it. But Netbeans is itself showing an error that bike1 is abstract, cannot be instantiated. If you can see this output, yeah, bike one is abstract, cannot be instantiated. This way we can Netbeans, even before we try to run this code, Netbeans is giving the output that it is an abstract class and it cannot be instantiated. If due to the small size of the font, if you are not able to see it properly, then you can write down this code and check whether you are getting the same output or not, same error output or not. So for the time being, we will just comment this out because this is the wrong line. And if we again run this code, yes, you are getting the proper output. What happens if we run this erroneous code? You see, it is asking me whether I want to run this compile with error or not. I'm hitting the run anyway. Yes. So we are both the methods are called, but after that an exception is thrown. So you can see that uh, creation of an object using the constructor of an abstract class is not possible. Okay, so better to comment out this line, right? So here we come to the end of today's session on abstraction. On the next video, we will be covering the topic of interface.